Yes, friends, so we are doing question number now 4. After question number 3, the answer of which was 2 by 3. Okay, the final answer of question number 3 was 2 by 3, 2 upon 3. Alright, so probability of question number in this case that consists of a boy with blue eyes or blue eyes. It says what is the random probability in question number 3. The probability of that a student chosen at random is a boy or has blue eyes. The probability of that was 2 by 3. That was the answer. Okay. After that, question number 4, what does it say? Now it says a card is drawn from a well-shuffled pack of playing cards. Alright. What is the probability that it may be a king or a queen? Now this is again, as I have talked about, addition theorem and multiplication theorem. Now still I am taking the questions based on this question is also based on addition theorem. What kind of addition theorem is this? Mutually exclusive and mutually non-exclusive, okay, or mutually inclusive events or partially overlapping events, okay. But this question is mutually exclusive events. Why? Let me just explain this question. So what is given? A card is drawn. Let me write here. A card is drawn from a pack of well-shuffled pack of cards. Well-shuffled pack of cards of playing cards. Pack of playing cards. Try to understand this question of playing cards. Then to find here, what we to find out here. Okay, so please go through the definitions which I have described for addition theorem and multiplication theorem. The two kinds of addition theorem for exclusive events, mutually exclusive events, and mutually non-exclusive or inclusive events. These are the two types of addition theorem. And similarly, two types of multiplication theorem for independent events and dependent events, right? Those are two multiplication theorems. So these questions will further clarify that what are the addition theorem and multiplication theorem, how they are used to solve the questions. That is the main objective of this whole topic discussed here. Okay, being discussed here. So let me take the what is the to find out here, to find the probability, we have to find out the probability that it may be a card is selected here. A card, this was also given that a card is drawn at random. A card is drawn from his well-shuffled. That is written there. Okay, I'm sorry. That is already written. So that card drawn is what is the probability that card drawn is a king, okay, is a king or a queen. That is maybe a king or queen, or is a king or queen. That is the question here. Or a queen. Okay, so this is union of the two events, but the two events, both events, king and queens, are naturally they are mutually exclusive, because there are 4 kings in playing cards, and 4 are queens in playing cards. Okay, there are 4 types of playing cards, and out of that one king, there are 4 kings and 4 queens. Similarly, one in each type of playing cards. So, okay, one king and one queen in each type of playing cards. So there are 4 queens and 4 queens and 4 kings. Okay, to solution. Let me now find out the solution. First of all, what are the total outcomes here that we know about? In a playing card there are 52 cards. So total outcomes or sample points, or events, we can say sample points in the sample space. Are the total outcomes or sample points in the sample space are 52, or simple as n into s, total number of equally likely cases, right, in the sample space is 52. This is the value. And then a queen is selected. Let us take A is the event. A is the event. A king is selected. A king is selected. And B is the event. And B is the event that a queen is selected. Simple. We have taken the two events separately. A queen is selected. That is the point here. So how many queens or kings, what the probability of selection of what the favorable cases, and then probability. So NA, number of favorable cases, that means number of favorable cases, that means number of favorable cases or favorable outcomes, favorable sample points, or favorable cases or favorable events is equal to 4, as 4 kings are there. Since 4 kings are there, okay. And B is equal to how much? And NB is equal to 4, as 4 queens are there, as 4 queens are there, in both the cases we have taken the similar type of wordings, right? So NA means number of favorable cases in event A means king is selected, and B is queen is selected. Total number of favorable cases in case of queen 4, in case of king 4. In both the cases there are 4 favorable cases. So what is the probability of selecting a king? Therefore probability of selecting a king, or that card is a king, that card selected is a king. First we have to find out what is the probability of selecting a king. That is equal to NA, number of favorable cases in the event A, divided by NS, number of total outcomes. This is 4 upon 52, 1 upon 13. Simple part. Okay, simple thing here. And similarly, in case of a queen, and the probability of selecting a queen, and the probability of selecting a queen is also equal to NB upon NS. Similar type of case. This is also 4 upon 52. That is 1 upon 13. But these two events are mutually exclusive, because there is no common point found in queens and kings. Both are separate playing cards. So, as we say, since, let me write here, since A intersection B is equal to 5, nothing is common. Therefore, probability of A intersection B is equal to 0 in this case. Why? Because both the events are mutually exclusive. Nothing is common between them. Therefore, probability of either a king or a queen selected is equal to. Therefore, by addition theorem, for mutually exclusive events, probability of A union B, A or B or both, is equal to probability of A plus probability of. Now substituting these values of probability of A and probability of B, probability of A is this, probability of A and probability of B both are equal, 1.13, 1.13. We can substitute those values. Okay, so this implies that 1.13 plus this is also 1.13, this is equal to 2/13. This is the answer here. This is question number 4 finally complete. Okay, this is the process how we have applied the addition theorem, because these are the mutually exclusive events. Try to understand. These are the how to use, these are the points or hints how to use addition theorem, okay, or for mutually exclusive events. Now let me take question number 5. What is question number 5 say? First let me read it and then write the given, what is given to us, and then solve it. Okay, let me take question number 5 here. Now question number 5 is of what kind? What is given to us? Let me first write. Now in question number 5 say, two students A and B work independently on a problem. Alright, work independently on a problem. The probability that A will solve it is 3/4, and the probability that B will solve it is 2/3. What the probability that the problem will be solved? You try to understand. In this case, both can solve the problems. Okay, so here they are mutually inclusive type. They have something common between them. So the second type of problem will be used or can be used here. Okay, let me take in different ways how to solve this in different ways. Let me just explain this in this question here. This question is of that kind which can be done in different ways. Okay, let me take this. What is given to us? We are given here two students A and B work independently right, independently on a problem, all right. The probability that A will solve the problem is 3/4. Means probability of A is equal to 3/4. It is given to us. While the probability that B will solve it and the probability that we will solve it is how much? 2/3. Sorry, it is 2/3. It is 2/3. All right. Then we have to find what is the probability that the problem will be solved. That's the point. We find here the probability. The probability that the problem will be solved. Or what is the probability that the problem will be solved? The probability that the problem will be solved is what? Okay, that we have to find out. Now we can solve it. First, let me take this in a first way. These two events are, or the two persons are solving the problem. They are independently doing this. Okay, so probability of A intersection B is probability of A into probability of B. This is given to us. If the problem is solved, it means problem solving capacity of A is what? Plus probability of B. In this case, we can do this because these two events are solving the problem by A is not affecting solving the problem by B. B can use probability of A plus probability of B minus probability of A intersection B. Here probability of A intersection B or A and B is probability of A into probability of B. Let me first solve it. The probability here, probability of A is equal to 3 by 4 and probability of B is equal to 2 by 3. This is given to us. Given. Since or as given. Let me check. As given to us or it is given to us. Alright, now we have to find, because these two problems are, they are independent also. They are not, solving the problem by A is not affecting solving the problem by B. They are mutually exclusive as well as independently based. Hence, if the problem is solved, then it can be solved either by A or by B or both or by both. That is the point here. Okay, so therefore the probability, since by addition theorem we know now probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. But now in this case probability of A intersection B is probability of A into probability of B. Why? Because here we have to apply the multiplication theorem type also, because these two events are independent. Solving the problem by A is not affecting solving the problem by B. Okay, because that B is separately solving it. So we can do this. Putting the value of probability of A, this is 3 by 4 plus 2 by 3 minus these two are multiplied. This is probability of A into probability of B. We have to multiply these two because they are two independent also. So we can multiply these two events. This can give us 3 by 4 plus 2 by 3 minus 3 by 4 into 2 by 3. So 3 cancel out. This is 1.2. Let me solve them. Now 12 is the LCM for these two. Let me take the last one is 1.2 because 2 upon 4 means 1.2. And for these two I have taken 12 LCM. So this is 4 3 12, 3 3 9 plus 3 4 12, 4 2 8 plus 8. Okay, and this will be minus 6 also because 2 6 12 minus 6. So that will be negative value 1.2. And if I take 12 LCM for 2 also in the denominator, that will be 6 in the numerator, so minus 6. Alright. Finally, what is the value here? So the final value is, so probability of A union B is equal to 17 by 12 minus 1.2 equal to 17 minus 6 upon 12. Why? Because this is 2 6 12. So 6 will be subtracted. This is 11 by 12. Because 17 minus 6 is 11. 11 upon 12 is the probability of the problem is solved. This is the answer here. 11 by 12. Now, if I solve it, that problem is to be solved. Is solved. Alright. And if I find that probability, the problem is not solved by A, by B, both. So if I find the complement probability of both A and B, and if I multiply them because they are independent, then also probability of A intersection B, in that situation B, probability of A naught into probability of B naught, means problem is not solved either by A or by B. So the two probability of not solving the problem of both A and B is to be multiplied. That problem will not be solved. So probability of A naught intersection probability of B naught will be equal to probability of A naught into probability of B naught. Those two probability are to be multiplied. And whatever value comes out, that to be subtracted from 1. Right, this is negative thing. Negative probability is subtracted from 1, so we get the solving the problem. The problem will be solved positive thing. that problem be solved. In that way also we can solve. Answer must be 11 upon 12. Let me take that. Okay, the problem is not solved by B, is not solved by A. Let me take solved by A. Then probability of that means probability of A naught is equal to 1 minus probability of solving by A. So this is 3 by 4. That means 4 minus 3 means 1.4. This is 1.4. And the problem is not solved by A. And problem is not solved by B. Not solved by B. This is second method I am talking about. And how we can solve this problem in second way also. How? That is not solved by B is equal to 1 minus probability of A naught. Not solved by means probability of B naught we are finding out. So this is probability of B naught equal to 1 minus probability of B. This is probability of B. So 1 minus probability of B, that means 1 minus 2 by 3. So this is 1.3. Why? Because 3 minus 2, 1.3. So probability is not solved by B is 1.3. Probability is not solved by A is 1.4. So probability is not solved by A and B will be given by, what is that? Probability of then probability hence. Probability of A and A naught is A naught and B naught, or A naught and B naught. Probability of A naught and B naught means probability of A naught intersection B naught is equal to probability of A naught into probability of B naught. What is this? That is probability, the problem is not solved. This is the problem here. This is equal to 1.4, probability of A naught is 1.4, we just calculated, and probability of B naught is 1.3. This is 1.12. So probability of the problem is not solved is 1.12. Now if I subtract it from 1 minus 1.12, that will give us the probability is solved. Hence, let me solve it here. Hence, the problem is solved. Solution. We are finding out. Hence, the probability that the problem is solved is equal to 1 minus probability that problem is not solved, that it is not solved, which we have just calculated. It is not solved, right? So what is that? It is not solved. Probability that it is not solved, that is 1 minus probability of this 1.12, because 1.3 into 1.4, that means 1.12. So this is equal to 11 by 12. Try to understand. 12 minus 1, 11 by 12. Same answer is coming. So this is also the process how to solve this problem. Okay. This is the second method. Third method can also be done. Let's suppose the probability is not solved by A. Okay. Not solved by B, let me take. So probability is solved by A but not by B. So we multiply their probabilities. Probability of A solving is 3 by 4. Probability B is not solving is 1.3, we just calculated. 3 by 4 and 1.3 is 1.4. 1.4, right? Now if it is added to what? The probability that B is solving this, so 2 by 3 plus 1.4. 2 by 3 plus 1.4. Now what the problem here? How to solve it? The problem is solved. Let me take. So B will solve it. B is not solving it. We multiply this. So this is 2 by 3 plus probability that A is solving it, but B is not solving. This is B is solving problem. And then A is solving, that means 3 by 4, but B is not solving. B is not solving, so this multiplied by 1.3. Okay, so this will give us 3 cancel out 1.4, 2 by 3 plus 1.4 will give us 12 LCM. 3 4 is 4 to the 8, 4 to the 12, 4 to the 12. So this is 11 by 8 plus 3, 11. This is also the process. How this is the question? Now suppose the problem is not solved by B, but by A. So what that probability? Then that way also we can solve it. And suppose the probability is not solved by A, but by B. So probability of A is solving, which is 3 by 4, plus probability of B's A is not solving, right? A is solving plus probability of A is not solving, but B is solving. B is solving is 2 by 3. That can also be done. 3 by 4 is the probability that A can solve it, and B only can solve. A is not solving. So what is that probability? 2 by 3. B is solving, but A is not solving is 1.3. So this, sorry, 1.4. A is not solving. This is A is not solving. B is solving, and A is solving here. So both are solving isolatedly. Here B is solving only, not A is solving. This A is solving. So if I do the sum of this, this is 1.2. So this is 3 by 4 plus 1.6. So 12 again LCM. 4 to your 12, this is 9. 6 to your 12, this is 2. 11 upon 12. This is also the process. Okay, so there are 4 methods I have discussed about. Okay, this problem is, the problem is solved not by A here. So A is solving plus only B is solving, only B is solving, not A is solving. So these two are added up, means the common thing which A and B were having, that has been subtracted. Only B is solving, A is solving. If they are added up, only B is B is solving and A is solving, not B. That multiplied, that is also 11 by 12. So the answer is 11 by 12 in both, in 4 methods I have discussed about here. Okay, so this is the process how to solve a particular problem. There are different ways. Okay, answer must be same in all the cases. So this, all these 4 cases are described. Okay, separately. I'll discuss about them if there is a requirement of this kind. But the 2 methods which I have described properly by writing something, but this was simply I did. Okay, so that is also giving the same answer, 11 by 12. Now let me take question number. Next question is the 6th one. What is question number 6 here? What is given to us? Let me first write it down. What is given to us? Okay, guys. So first let me solve it here. No, let me clean this. Yes, guys. So this is the question number 6 we are doing. Let me take this question here. Question number 6, what is given to us? Let me first check it, that what is given. The odds in favor of A hitting a target, okay, are 4:5. Here the ratio of given odds in favor of A are 4:5, okay, and that of B are 3:4. Find the probability of the target being hit at all when they both try. So this is also again, the problem is solved, the target is being hit. Same kind of situation is here also. Okay, that I have to take. So what is given here? The odds here, the odds in favor of A, in favor of A hitting a target. This is hitting a target. Hitting a target, right? Hitting a target in 6th question is R. Here the odds here, odds in favor of A hitting a target are 4:5. Now this is 4:5. This is the first thing here. Secondly, it says, and that